Good morning, students. From the class in the morning, I found out that the concept of hole conduction is not very clear even now in many of your minds. So let me explain this once again. The hole conduction is the mechanism of conduction which happens in semiconductors only. In semiconductors, let us consider a semiconductor silicon which has been doped with indium. Indium is a acceptor impurity. So it is a trivalent impurity and it is a acceptor. That means it is having only 3 electrons in the valence band. So in the valence shell, because only 3 electrons are there, it is able to form 3 bonds with 3 neighboring silicons. The 4th silicon is having an unsatisfied bond. That means there is only 1 electron in this bond, even though 2 are required for making the bond. So this absence of electron, this we call it as a hole. Hole is nothing but an absence of electron which is required. So now if you look at the picture here, we have applied the battery, positive on this side and negative on this side. This hole, because it is absence of electron, it is associated with a positive charge. So the positive of the battery will attract the electrons, while the negative of the battery will attract the holes. Now the hole cannot travel from one place to another, but we say that hole conduction is taking place because the neighboring electron from the neighboring atom can jump into this hole because it is being attracted by the positive of the battery and it is having vacancy nearby. So the electron from this atom cannot jump here, but the electrons from the neighboring silicon atoms can jump here, because the electron from here cannot jump because there is no hole in this vicinity, but this electron can jump because it is having a hole in the neighborhood. So when this electron jumps from here to here, then this becomes satisfied octet. This bonds become satisfied octet, whereas the silicon here will have a unsatisfied. That means only 7 electrons will be there in the outer shell of this silicon. So look at the figure 2. You can see that the electron has jumped from here to here. So the indium is having 4 electrons in the outermost shell and forms 4 covalent bonds, while this silicon is not having 1 electron because it has jumped here. So it is having unsatisfied bond. So we can, in effect, we can say that the hole has moved from here to here. Now because the battery is still being applied, so these electrons are still getting attracted towards positive of the battery. So from the neighboring silicon, an electron can jump from here to here. So when the electron jumps from this silicon to here, this silicon, it satisfies the hole, but the hole is left behind in this silicon. So now look at the figure 3. You are having a hole here and this has been satisfied. Now if you compare from figure 1 to figure 3, you can see that the hole has moved from here to here. Now still the battery is being applied, so this silicon can move, this electron can move from here to into this hole and satisfy this hole, and new hole is formed in this place. So in the figure 4 you can see that there is a hole here and this hole has been satisfied. So in effect, from figure 1 to figure 4 you can see that the hole has moved from here to here to here to here, like this. So the hole is moving towards the negative of the battery and it is associated with a positive charge, but in fact the electron is moving from here to here to here, like this. From here to here, from here to here, and from here to here, like this the electron has moved. So this hole conduction is the movement of electrons in the valence band by jumping into the neighboring holes. So this type of conduction takes place in p-type semiconductor. I hope the concept is clear. If not, please watch the video 2 or 3 times and post your questions in the discussion forum. Thank you.